Now, the next method we are going to look at is the Newton-Raphson method. It is also known as the tangent method. Now, this method uses the assumption that given the equation f of x equals 0, whose derivative exists in an interval whose derivative exists in an interval AB. There exists a root x. X is element of AB, where x is the intersection of the tangent line and the curve y equal f of x. Thus, by successive approximation, we get to the root. Now, let's look at the graph of what we are trying to explain here. We have this, and then we have a curve, so that there is also tangent line at this point, call it x1. Have another tangent line, and this one this time is at x2. So in this point we have a point xo. There is another point from this particular tangent that approximates to here. Okay, this is the tangent, and this place, call it x, and here we have y equal f of x. This is the curve y equal f of x. This is the y-axis and the x-axis. So if we start the iteration from here, you get to the point x, which corresponds with the tangent. Now let us derive the iteration formula. Derivation of Newton-Raphson iteration formula. Now, we recall that the equation tangent is given by x minus xo equal f prime of x, where f prime of x is the gradient. Or tangent, the gradient is also the tangent or slope. So, and this is equation of a line in 1 point form. This is the gradient. If you cross multiply, the gradient now, which is f prime of x, will multiply this. Okay. Now, since the tangent cuts the x-axis at x1 and 0. Now look at it. This is the tangent we are considering, and this is x1, and here corresponds to 0 for the y-axis. We substitute into equation 1 at this place. If you substitute the coordinates, you have 0 y sub o and x1 minus xo equal f prime of xo. Okay. Now, by cross multiplication, we have x1 minus xo times f prime of xo equal minus y sub o. Okay, so in this aspect, we'll let y sub o equal f of xo. If you do that, you have x1 minus xo f prime of xo minus f of xo. Okay, let us then divide through by f prime of o. Dividing through by f prime of xo. Divide through by f prime of xo. We'll have x1 minus xo, okay, equal minus f of xo over s prime of xo. Okay, so let us transfer here to here. So we have 1 equal x of o minus f of xo over f prime of xo. Now, x1 equal xo minus f of xo over f prime of xo. So that in general, Sn plus 1 will be equal Sn minus f of Sn over f prime of Sn. For n equals 0, 1, 2, 3, and so on. So this becomes Newton-Raphson formula for iteration. So we are going to take an example and see how we can apply this.
Find the real roots of the equation. 3x equal cos x plus 1. Using Newton-Raphson method in the interval 0 and 1. Correct to 4 decimal places. So we now take the solution. Let f of x equal 3x minus cos x minus 1. You know, here what I'm doing is to carry cos x to this way, and I will have minus cos x. Carry 1 to this place, I will have minus 1. So f of x equal 3x cos x minus 1. Now, since the interval is between 0 and 1, I will now test whether there is a root. Then f of 0 equal 3 times 0 minus cos 0 minus 1. Cos, that will give us minus 2 because cos 0 is 1. So we have minus 1 minus 1, which is minus 2. F of 1 is 3 times 1 minus cos 1 minus 1. So that we have 3 times 1 minus cos 1 minus 1. So that gives us 1.00. Now, since f of 0 times f of 1 is less than 0, there exists a root in the interval 0 and 1. Now, there is something we want to do here. There is something I want to show here, because most times this interval, though it is just one interval, but the iteration can be very long if you don't know this small secret that I want to put there. Now I'm going to divide this interval. I'm going to test this interval by dividing it to know the side that the root really lies. Now I want to divide it by 2, and this is 0.5. So f of 0.5 will be equal to 0.5 minus cos 0.5 minus 1. So if I have that, I have 0.5 minus cos 0.5 minus 1. So that gives me minus 0.4999. Okay, now f of 0 is negative. It gives me negative. F of 0.5 give me negative. So what it means is that between 0 and 0.5, since they don't have opposite sign, there is no root between 0 and 0.5. So to make the iteration very fast, I'm going to choose my starting point from 0.5. That is because from 0.5, f of 0.5 give me negative, f of 1 is positive. So meaning that from here to here, since there is opposite sign, the root is this way, and not here. There is no root from 0 to 0.5. But there is root from 0.5 to 1, because f of 0.5 is negative, f of 1 is positive. So I'm going to choose xo equal 0.5. Why do I do that? I'm going to start from 0.5 to iterate, because I know very well that there is no root this way. Okay. Then f of 0.5 that is f of x2 equal, we have got here to be minus 0.4999. Now f prime of 0.5 give us 3 plus sine x, so that 3 plus sine x, so that which is equal 3 plus sine 0.5. Now if we say 3 plus sine 0.5, we have 3.00887.
It means that x1 will be equal xo minus f of xo, yes, f prime of xo, and that will give me xo is 0.5 minus f of xo is minus 0.4999 over f prime of xo, which is 3.0087. Okay, so this will give me 0.5 plus 0.4999 over 3.0087. Okay, 0.4999 divided by 3.0087. We have 0.5 plus 0.1662. So that is x1. If you add this, you have 0.5 plus 0.1662. 0.6662. Next, we'll find f of x1. That is 0.6662 minus cos 0.6662. Yes, minus 1. To do that, you have 3 times 0.6662 minus cos 0.6662 minus 1. This gives us minus 0.00133. Okay, now we need f prime of x1. Of course, that is 3 points sine 0.6662. We do that, we have sine 0.6662. And that gives us 3.011 or 012. Yes, or 0116. 0116. Okay. Now, x2 will be equal x1 minus f of x1 over f prime of x1. And that gives us x1. x1 is 0.6662 minus f of x1 is minus 0.00133 over f prime of x1 is 3.0116. So 0.6662 plus, this time this minus time minus plus 0.00133 over 3.0116 will give us 0.6662 plus, you divide this, you have 0.00133 divided by 3.0116. This gives us 0.00044. Now, if you add this, we have 0.6662 plus 0.00044, giving us 0.6666 to 4 decimal places as required. Alright, so we now, this is x2. We now find f of x2, which is equal 0.6666 minus cos 0.6666 minus 1. Then we now find f prime of x2, which is 3 plus sine 0.6666. Okay, so let's compute the two. If you compute the first one there, we have 3 0.6666 minus cos 0.6666 minus 1. This gives us minus 0.00013. Now, this one gives us 3 plus sine 0.6666. That gives us 3.0116. Now, S3 will be equal x2 minus f of x2 over s prime of x2, and that will give us x2. x2 is 0.6666 minus f of x2, which is minus 0.00013 over f prime of x2, which is 3.0116. Now, we now have 0.6666 plus, because this must give us plus 0.00013 over 3.0116. So 0.6666 plus now 0.00013 divided by 3.0116. This gives us 0.00004. Now if you add this, you have 0.6666 plus 0.0004 0.00004 give us 0.6666, okay, to 4 decimal places. Now notice that S3 and S2, they are the same. So since S2 equal S3, the roots converges at x equal 0.6666. So that is how we use the Newton-Raphson method. Yes, that's how we use it. Now we are going to look at another example by Newton-Raphson method. Find the cube roots of 6 using the Newton-Raphson method. So we are going to find the cube roots of 6 using Newton-Raphson method. And let's look at the solution. Let the cube root of 6 be x cubed. So that implies that x cubed equals 6. Now notice that cube root of 6. Or if I don't want to write it like that, I can say f of x equal x cubed minus 6. See that? Now, here we are going to look at the interval of existence of these roots. Now let's try 1. F of 1 will give us 1 cube minus 6. Of course, this is minus 5. F of 2 will be 2 cube minus 6. This is 8 minus 6, which is 2. Alright? So since f of 1 times f of 2 is less than 0, there exists a root in the interval 1 and 2. Okay, let us start the iteration. We are going to choose SO equal 1 as the starting point. And we have known that f of 1 equal minus 5. What about f prime of x? F prime of x equal 3x squared. So that f prime of 1 is 3 times 1 squared, which is 3. Okay, so we can then continue that x1 will be equal xo minus f of xo over f prime of xo. And we know that this will be the same. xo is 1. F of xo, that is f of 1, is minus 5 over f prime of xo, which is 3. So this is equal 1 plus 5 over 3, which is equal 1.16667. And that will give us, that is 1 plus, because 5 divided by 3 is 1.6667 approximation. So we have 2.6667. Now, we'll now find f of x1, which is 2.6667 cube minus 6. 2.6667 cube minus 6 will give us 12.9637. Now, f prime of x1 is 3. 2.6667 squared. 3 times 2.6667 squared. That gives us 21.3339. Okay, so x2 will be x1 minus f of x1 over f prime of x1. Now, x1 is 2.6667 minus f of x1 is 12.9637 over 21.3339. That will give us 2.6667 minus 12.9637. 12.9637 divided by 21.3339. That gives us 0.6077. We minus this, we have 2.6667 minus 0.6077. Give us 2.059. Now, f of x2 equal 2.059 cube minus 6. And that will give us 2.059. 2.059. Okay, let's compose this again. 2.6667 minus 0.6077. Yes, 2.059 I need to compute f of x2. That is cube minus 6 will give us 2.7291. Now f prime of x2 is 2.059 squared. We do that with 2.059 squared. We have 12.7184. Now x3 will be equal x2 minus f of x2 over f prime of x2. And that will give us x2 is 2.059 minus f of x2 is 2.7291 over 12.7184 equal 2.059 minus 2.7291 divided by 12.7184, 0.2146, 2.059 minus 0.2146, 1.8444. Now f of x3 equal 1, f of x equal 3, 1.8444 minus cube minus 6. We have 1.8444 cube minus 6 giving us 0.2743. F prime of x3 equal 3, 1.8444 squared. Compute that, we have 3, 1.8444 squared. Give us 10.2054. Now x4 is equal x3 minus f of x3 over f prime of x3. And that will give us x3 is 1.8444 minus f of x3. F of x is 0.2743 over f prime of x3, which is 10.2054. Then we have 1.8444 minus 0.2743. 0.2743 divided by 10.2054. It was 0.0268. Okay, 688. Now, if we minus this, we have 1.8444 minus 0.02688. That gives us 1.8175. Now, f of x4 will be equal 1.8175 cube minus 6. We compute that, we have 1.8175 cube minus 6. That will give us 0.00376. Now f prime of x4 is 3, 1.8175 squared. To do that, we have 3 times 1.8175 squared. That gives us 9.9099. Okay, so x5 equal S4 minus f of S4 over f prime of S4, and that will give us S4 is 1.8175 minus f of S4 is 0.00376 over 9.9099. So there we have that S5 will be 1.8175 minus, we divide this 0.00376 divided by 9.9099. We have 0.000379. Of course, that will give us 1.8175 minus 0.000379. 1.8171. Okay, this was 1.8175. So we are very close. Now we'll look f of x5. That will give us 1.8171 cube minus 6. To do that, we'll have 1.8171 cube minus 6 will give us minus 0.00020. Okay, now f prime of s5 give us 1.8171 squared. Computing that, we have 1.8171 squared. That gives us 9.9056. Now, x6 equal x5 minus f of x5 over f prime of x5. So, and that will give us s5. S5 is 1.8171 minus f of x5, which is minus 0.00020 over 9.9056. So that will give us 1.8171 minus, okay, plus, because of this minus. So plus 0.00020 over 9.9056. So 1.8171 plus phi, divide this 0.00020 divided by 9.9056. We have 0.00002. Now, if we add there, we have 1.8171 plus 0.00002. Okay, still give us 1.8171. So since x5 equal x6, the root converges to x equal 1.8171. So now if we also look at the cube root of 6 from your calculator, cube root of 6 will give you 1.8171 to 4 decimal places. So which means we are correct. The next method we are going to look at is the second method. To recall that the secant is a line which cuts the curve y equal f of x at least 2 points. Now let us see the diagram. So this is point B. x1 f of x1. We have x1, x2, and this is xo, and this is point A with xo, f of xo. So the first point is A. It has coordinates x subscript o, f of x subscript o, and here is x1, f of x1. The gradients of a line which passes through 2 points is given by you know that this is the gradients of a line which passes through 2 points from geometry. Okay, now since the secant passes through x2 and 0, that is from the graph, you see that this is where the line cuts the x-axis at x2 and 0. We substitute the coordinates into equation 1 above, and we'll have 0 minus y subscript 0, x2 minus x0 equal y1 minus y subscript 0, x1 minus x subscript 0. By cross multiplication, I will have x subscript 2 minus x subscript 0 times y1 minus y of 0 equal minus y of 0 x1 minus x of 0. Alright, now here we are going to divide. We are going to divide through by y1 minus y subscript 0. Adding through by y1 minus y subscript 0, we'll have x2 minus x subscript 0 equal minus y subscript 0 x1 minus x subscript 0 over y1 minus y0. Okay. Then x2 will be equal x subscript 0 minus y subscript 0 x1 minus x subscript 0 over y1 minus y subscript 0. Now, if we let y subscript 0 to be f of 0, y subscript 1 to be f of 1, we'll have something like this. That x2 will be x subscript 0 minus f of x subscript 0 Then x1 minus x of p0 over f of x1 minus f of x0. So in general, Sn plus 1 will be equal x n minus 1 minus f of x n minus 1 x1 minus x0 over f of Sn minus f of Sn minus 1 for n equal 1, 2, 3, and so on. So this becomes the second formula for iteration. N start from 1, 2, 3. So that by the time we have n is 1, so we come back to x2. When n is 1, we have 1 minus 1, which is x sub is 0. 1 minus 1 give us that. Then when n is 1, we have f of s1. Right, so this is how the second is derived. The second formula of iteration is derived. And we are going to pick one example so that we see how it works. Now, we are going to take an example for the second method. Find the interval of existence of a real root for the equation x cubed minus 2x minus 5 equals 0 using the second method. Correct to 3 decimal places. Okay, so let's look for the interval of existence of real root of this equation by second method. So the solution, we have, let f of x equal x cubed minus 2x minus 5. Okay, so f of 2 give us 2 cubed minus 2 times 2 minus 5. And this will give 8 minus 4 minus 5. And that gives us minus 1. Now, f of 3 will be 3 cubed minus 2 times 3 minus 5. Well, this is 27 minus 6 minus 5. That is 16. That is 27 minus 11. Right, since f of 2 times f of 3 is less than 0, because if you times these two now, you have negative 16. So there exists a root in 2 and 3. In this interval 2 and 3, there's a root. But there's something I want to do so that we look for the convergence faster than. I want to divide this interval and also know the side that it is. Most times it helps for convergence to come quickly. Let me divide it into 2 to have 2.5. So f of 2.5 will be 2.5 cubed minus 2 times 2.5 minus 5. That will give us 2.5 cubed minus 2, 2.5 minus 5. This gives us 5.625. Okay, this is positive. Now 2.5 is positive, 2 is negative, 3 is positive. So meaning that from 2.5 to 3 there's no root that side. Root is this way, 2 to 2.5, there's root there. So now I can now choose XO equal to the starting point equal to S1 equal 2.5. You know, if I have not divided it, I will have choose my S1 to be this one. But now I know that the root is this way, so I'm choosing here. Yes, so that using Sn plus 1 equal Sn minus 1 minus f of Sn minus 1 Sn minus 1 over f of Sn minus f of Sn minus 1. S2 will be equal x substitute 0 minus f of x0 s1 minus x0 over f of s1 minus f of x0, so that we have x0, that's s of 0 is 2, minus f of 2, which is minus 1. Then x1 is 2.5, s of 0 is 2, over f of 1, which is 5.625, minus f sub 0, that is minus 1. Okay. So with that we have 2 minus 1, 0.5 over 6.625. That is minus 1 times minus 1 is plus. So, and that gives us 2 minus, or 2 plus 0.5 over 6.625. 2 plus, now 0.5 divided by 6.625, it was 0.0755. That gives us 2.0755. Next we'll find f of x2, and that gives us 2.0755 cube minus 2, 2.0755 minus 5. So 2.0755 cube minus 2.0755 minus 5 minus 0.2104. Now we have x3. x3 is equal x1 minus f of x1, x2 minus x1 over f of x2 minus f of x1, and that will give us x1. Now x1 is 2.5 minus f of x1, which is 5.625. Then also have x2. x2 is 2.0755 minus x1. That is minus 2.5 over f of x2, which is minus 0.2104 minus f of s1. f of s1 is 5.625. So we have something like this: 2.25 minus 5.625, then 2.0755 minus 2.5 is giving us minus 0.4245 over, we have minus 0.2104 minus 5.625. So that gives us minus 5.8354. Okay. And that becomes 2.5 minus 5.625. Okay. Now we are going to multiply these two so that we'll have the plus of it. We have 5.625 times 0.4245. That gives us plus 2. Okay, so let's pick 2. 2.3878 divided by minus 5.8354. Now this will give us 2.5 minus because of this. So here we have 2.3878 divided by 5.8354. We then have 0.4092. Okay, so that gives us 2.5 minus 0.4092, which is 2.0908. Now we find f of x3, and that is 2.0908 cubed minus 2, 2.0908 minus 5. Computation of this will give us cube minus 2, 2.0908 minus 5, and that gives us minus 0.04178. Okay, so we need x4, and x4 will be x2 minus f of x2, then x3 minus x2 over f of x3 minus f of x2, which is equal to 0.0755 minus f of x2, because f of x2 is minus 0.2104. Now x3 is 2.0908 minus x2 is 2.0755 over f of x3 is minus 0.04178 minus f of x2. F of x2 is minus 0.2104. So this gives us 2.0755 minus 0.2104. Then this will give us 2.0908 minus 2.0755. That gives us 0.0153 over, now this is minus 0.04178 plus because of this 0.2104. That gives us 0.168862. Now we are going to multiply this. We have 0.2104 times 0.0153. That will give us plus 0.00322 over 0.16862. 2.0755 plus, you have 0.00322 divided by 0.16862. Give us 0.01909. If you add this, you have 2.0755 plus 0.01909. That gives us 2.0946. Okay, so the other one was 2.0908. Now we'll look for f of x4. F of x4 gives us 2.0946 keep minus 2.0946 minus 5. This computation will give us 2.0946 keep minus 2.0946 minus 5. This is 0.00054. Right. Now we'll look for x5, and that will be x3 minus f of x3. Then we have x4 minus x3 over f of x4 minus f of x3. Okay, this will give us x3 is 2.09, so it's 2.0908 minus f of x3 is minus 0.04178. Then x4 is 2.0946 minus x3. x3 is 2.0908 over f of x4 is 0.0000. Okay, 0.000, yeah, 54 minus f of x3. F of x3 is minus 0.04178. Okay, and that will give us 2.0908 minus 0.04178. Now we'll subtract this. 2.0946 minus 2.0908 equal 0.0038. Okay, over, we go here, we have 0.00054 plus because of this 0.04178. 0.078. That gives us 0.04232. Now 2.0908, and this is plus because of this. Okay, so let's compute this way. 0.04178 times 0.0038, and that gives us 0.00016 approximation. Now if you add this, we have 2.0908 plus 0.00016. This gives us 2.09096. Okay, of course we were asked to correct to 3 decimal places, so I think we can correct this to be 1, so that we'll start the computation there, make it easier. Now we have 2.091 cube minus 2, 2.091 minus 5. We do that, we have 2.091 cube minus 2.091 minus 5. This gives us minus 0.0396. Now x6 is equal x4 minus f of x4, x5 minus x4 over f of x5 minus f of x4. And this will give us x4. So x4 we have 2.0946 minus f of x4 is 0.00054. Then s5 is 2.091 minus s4. s4 is 2.0909. If you like, you can call it 5. Yes. Over 5 for 3 decimal place over f of s5. f of s5 is minus 0.0396 minus. Now f of s4 is 0.00054. If we compute this, we have 2.095 minus 0.00054. Then this way will give us 2.091 minus 2.095 as minus 0.004 over, and if we go this way, we'll have minus also. So that is minus 0.0396 minus 0.00054. Give us minus 0.040. Alright. So 2.095 minus, we will compute this. We have 0.00054 times 0.004. This gives us 0.0000222 over 0.040. Now this minus plus this time, this minus is plus, then this one divided. That's how we have the negative. Now if you look at this, 0.00022 divided by 0.040 will give us 0.004. 0, 0, 0, then we have something like this. 2.09.095 minus 0.00005. Now, if we compute that, 2.095 minus 0.00005 give us 2.095. Okay, so that will give us, that's equal 2.095. Now, f of x6 will be equal 2.095 minus 2.095 minus 5. And we have 2.095 cube minus 2.095 minus 5. That will give us 0.005. Right. Now x7 equal x5 minus f of x5, x6 minus x5 over f of x6 minus f of x5. We do that, it will be equal to x5. Now x5 give us, we have x5 to be x5 2.091 minus f of x5 is minus 0.0396. Then x6 is 2.095 minus x5 is 2.091 over f of x6 is 0.005 minus f of x5 is minus 0.0396. So that will give us 2.091 minus 0.039, then 2.095 minus 2.091 will give us 0.004. Now here the downside we will have 0.005 plus. Now it is plus because minus times minus. 0.0396. Then we have 0.0446. Okay, so here we have 2.091 plus. Now it's plus because of this. So we have 0.039 times 0.004. That gives us 0.00016 over 0.0446. So this becomes 2.091 plus, and if we divide 0.00016 by 0.0446, we'll have 0.00359. We add this, we'll have 2.091 plus 0.00359. Okay, and that gives us 2.095 to 3 decimal places. Therefore, since x6 equal x7, the root converges at x equal 2.095. So that is where the root converges, and that is the second method. Let's look at another subtopic. The next iteration method we are taking is the Chebyshev method. We recall that given the equation f of x equals 0, the Taylor series expansion of f of x about x equal sk is given by f of x equal f of sk plus x minus sk, f prime of sk over 1 factorial plus x of xk, f prime prime of xk over 2 factorial plus x minus sk. Okay, this is cubed, sorry, this is squared, so cube over 3 factorial f prime prime of sk plus x minus sk raised to power 4 f, this is f prime prime prime, so this is f prime of sk over 4 factorial. Now, neglecting the term, we neglect this term, the term, which term? X minus sk cube over 3 factorial f prime 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 of sk, and the higher order, that is from this side up, because we assume that on that side the error tolerance the error is too small that we can neglect. So if you neglect from here, you have something like this: f of x equal f of sk plus x minus sk f prime of sk over 1 factorial plus x minus sk squared f prime prime of sk over 2 factorial. Or we can write this in this form: f of xk plus x minus xk f prime of sk over 1 factorial, then 1 factorial is 1, plus x minus sk squared f prime prime of sk over 2 factorial is 2 equals 0. So we can write like that. Now, dividing through by f prime of sk, we divide through, we have f of sk over f prime of sk plus x minus sk plus x minus sk squared over 2, yes, f prime prime of sk equals 0. Okay, I'm going to transfer this to this way and also transfer this. If I do that, I will have x minus sk, which is this term. Then this go this way. If it goes that way, I will have minus f of sk over f prime of sk minus 1 over 2 x minus sk square f prime prime of sk, f prime prime of sk over f prime of sk. Notice that here, when we divide through, we are going to divide this, we are also divide here by f prime of sk. So as we divide, we have this. Now, I'm going to substitute. See what I'm going to do here? I'm going to substitute f of sk over f prime of sk square in place of x minus sk square. So if I do that here, I'm going to get something like this: x minus sk equal minus f of sk over f prime of sk minus 1 over 2. Then I have f of sk over f prime of sk square, then f prime prime of sk over f prime of sk. Of course, what it means there is the same as writing minus f of sk over f prime of sk minus 1 over 2. Then this could be written as f of sk square over f prime of sk square. Then we have f prime prime of sk over f prime of sk. You see, what it means that the downside is about cube. Is this times this give you cube. Then we have this to be square. If we don't want to write in this way, write in this way. Now, what it means there is that x equal sk, if I transfer this, minus f of sk over f prime of sk minus 1 over 2. Then I have f of sk over f prime of sk square f prime prime of x over f prime of sk. So in general, Sn plus 1 or sk plus 1 will be equal sk minus f of sk over f prime of sk minus 1 over 2 f of sk square over f prime of sk, then f prime prime of sk over f prime of sk. Okay. For k equals 0, 1, 2, and so on. So we have the Chebyshev method using this formula. Let us take an example using the Chebyshev method. Find the real roots using Chebyshev method of the equation x cubed minus 5x plus 1 equals 0 in the interval 0 and warrant to 4 decimal places. Now let's take the solution. Let f of x equal x cubed minus 5x plus 1. You see, f of x equal this. So that f of 0 will equal 0 cubed minus 5 and 0 plus 1. Now, f of 1 is 1 cubed minus 5 times 1 plus 1. Now, f of 0 will give us 1. F of 1 give us minus 3. You know, this is minus 5. 1 plus 1 is 2, so we have minus 3. Now, since f of 0 times f of 1 is less than 0, there exists a root, at least a root in the interval 0 and 1. Okay, so let us choose the starting point. Choose xo equal 0. We are going to start on the point 0 to iterate. Now we will find f of 0. F of xo equal 1. We know that, if 0 is a certain point, then f of 0 is 1. Now, another one is, we can look for f prime of x0. That is, we are going to differentiate this. We differentiate to have f prime of x. Let us take f prime of x first, to have 3x squared minus 5. So f prime of x0 equal f prime of 0, and that gives us minus 5. We also need f prime of x, which gives us 6x, so that f prime of x0 will give us 0. F prime of x0 is f prime of 6 times 0, which is 0. So that now x1 will be equal x0 minus f of x0. Yes. Then we have over, yes, minus, now f prime of x0 minus 1 over 2 f of x0 over f prime of x0. Then we have f prime of x0 over f prime of x0. Now notice that this is square. So if we compute that x0 is 0 minus f prime of x0, that is f of 0. F of 0 is 1 over f prime of x0, which is minus 5 minus 1 over 2. So 1 over 2 is 0.5. And here f of x0 is 1. That is f of 0. F prime of x0 is minus 5 square. F prime of x0 is 0 over f prime of 0, which is minus 5. Okay, because of this 0, so we have minus, we have 1. This is 0, so this and this is 1 over 5. That is 0.2. That is x1. Then you also need f of 0.2, that is f of x1. That will give us 0.2 cubed minus 5, 0.2 plus 1. If we compute this, we'll have 0.2 cubed minus 5 times 0.2 plus 1. Now give us 0.008. Okay. Now, f prime of 0.2 is 3 0.2 minus 5. Then that will give us 3 0.2 square. Yes, 3 times 3 times 0.2 square. This is square. Because if you differentiate it, we have 3x squared minus 5. Then that will give us 3 times 0.2 square minus 5. Give us minus 4.88. Next, we'll find s prime of 0.2. That will give us 6 times 0.2. Now 6 times 0.2 is 1.2. So after having that, we are going to now compute x2. x2 then become x1 minus f of x1 over f prime of x1 minus 1 over 2 f of x1 over f prime of x1 square f prime of x1 over f prime of x1. So after having that, x1 is 0.2 minus f of x1, which is this 0.008 over f prime of x1, which is minus 4.88 minus 0.5, that is 1 over 2. Then we have f of x1 here give us 0.008 over f prime of x1. F prime of x1 is minus 4.88 square. Then f prime of x1 is 1.2 over f prime of x1, which is minus 4.88. Okay, then we will have 0.2 plus, of course, if we divide this will give us plus, so we have 0.008 divided by 4.88. That will give us 0.0016 minus 0.5. And let's look at this. This place is the same with this. So only that we'll square this. So we have 0.0016 squared. Will give us 0.00000. Okay, 26. Now, if we go this one, we have 1.2 divided by 4.88. That gives us minus 0.24459. Then we are going to compute this. 0.2 plus 0.0016 minus 0.5, 0.000026 minus 0.2459. Then we have 0.2016. Now, f of 0.2016, that is f of x2, will equal 0.2016 keep minus 5, 0.2016 plus 1. And let's compute that. 0.2016 keep minus 5, 0.2016 plus 1. That will give us 0.000194194. Okay, so f prime of 0.2016, that is to say f prime of x2, will give us 3. 0.2016 square minus 5. You have that here. 0.2016 square minus 5. That gives us minus 4.8780. Now f prime prime of 0.2016 will give us 6 times 0.2016. Now if you compute that, 6 times 0.2016 will give us 1.2096. Alright, so now go for x3. x3 will equal x2 minus f of x2. f of x2, then we have over f prime of x2 minus 1 over 2 f of x2 over f prime of x2 square f prime prime of x2 over f prime of x2 is equal x2. Now x2 is 0.2016 minus f of x2 0.000194 over f prime of x2, which is minus 4.8780 minus 0.5, that is 1 over 2, times 0, that is f of x2, which is 0.000194 over minus 4.8780. Then f prime of x2 is 1.2096 over f of f prime of x2. F prime of x2 is 1.2096. Then f prime of x2 give us minus 0.8780. So the competition becomes 0.2016. Then if you look at this, we have plus here because of this and this. And then if you do that, we have 0.000194 divided by 4.8780. Here we have 0.000397 minus 0.5. Then here is the same thing with here. So we have minus 0.0000, okay, 397. Then here is 1.2096 divided by 4.8780. So this is minus 0.24479. Okay. Next, we are going to compute the whole value now to have. Now, this is 0.2016. So let's add all of them. They will have something like this: 0.2016 plus 0.0000397 minus 0.5 times minus 0.00003. Okay, this is square. This is square. So we will compute first to get the value here. So you get the right result. That is 0.2016 minus, okay, plus 0.0000397 minus 0.5. Okay, this one will be square of the place because of this square. So square. Now if we square that and look at that, that will give us positive because of this. But 0.0003397 square is giving us 0.00000. That is 1, 2, 3, 4, 5, 6, 7, 8. We have about 9 zeros. 157. Then why this side is minus 0.2479. Okay, so it's now we'll compute its steps to have 0.2016 plus 0.0000397 minus 0.5 times 0.00000000157. Then we have minus 0.2479. Okay, and this gives us 0.2016. Yes, look at that, 4 decimal places. Now, if you look at this, you now see since x2 equal x3, the root, because for x2, we had 0.2016. Then we compute x3 to have the same 0.2016. So since x2 is equal x3, the root converges at x equal 0.2016. So that is how we compute using the Chebyshev method. Alright.
Welcome back. Is there anything you find it difficult to understand? If yes, send your question in the comment box. Subscribe to this channel, hit the notification button so that you'll be getting new videos that are posted. You can share these videos to other platforms. Thank you.